great webinar and show to go through today. But first, as always, I love to see where everyone is tuning in from. So let us know in the chat whereabouts you're listening and watching from. I'll start. I'm tuning in today from Paris in France. It's not where I live, but it is where our offices are that I'm here. And Feross, whereabouts are you tuning in from today?
I'm coming from San Francisco, California.
San Francisco. All right, we've got Toronto, Nigeria, Avin, San Diego, India. I always love to see the reach that we can get. Ukraine, welcome. Czech Republic. Czech is one of my favorite countries. I was at a conference in Prague this year. It's my first time there. Nepal, Serbia, Portugal. I was in Porto last week at Porto Hard Tech Conference. Very, very cool place. Very wet last week, but super cool place. UK, lots of different countries. Well, I love to see where that is. It also takes up a bit of time whilst we're waiting for everyone to join, but great to see so many different places here. South Korea, we're still going. So a little bit of a run through of what we're going to go through today. So intros, which is currently what we're doing. Then we're going to talk about a little bit. You have to suffer through me talking for about 10 minutes, where I'm just going to discuss what are supply chains, if there is in fact a supply chain, what it looks like, and then I'm going to talk very quickly about some of the anatomy of a supply chain attack. What a supply chain attack looks like in practice once it's been done. Then I'm going to hand it over to Feross, who's going to run through a presentation about the challenges of open source and supply chain security. So this is something that really affects all areas of software development today, which we'll elaborate on, I'm sure. We're going to do a little bit of a lightning demo of Socket Security, which is a fairly new tool to the ecosystem. So I'm excited about that. And then, of course, we're going to go through a Q&A. So if you're in Crowdcast, we're also streaming to some other places, but the main platform is in Crowdcast. And if you're in Crowdcast, to the right-hand side of your screen, you'll see some options. One of those options is to ask a question. So feel free to ask questions at any time during the presentation. We're going to get to them at the end, but you can also upvote and downvote and comment on other people's questions so that we get kind of the ones that people want to hear. We make sure that we get to them. So feel free to do that. And at any point, feel free to communicate in the chat. We always love participation. So that's the general flow of what we're going through today. So without further ado, I'm just going to get started. I'm going to go straight into it. So is there really a supply chain, and what does that actually look like? So supply chain, we're kind of familiar in if we're talking about typical manufacturing, right? You have your raw components and materials, you have your assembly lines, you have your kind of testing lines, and then obviously packaging and shipping, and we get the end product. You can imagine that going through the car, manufacturing, all those things happening. There's lots of moving components. Obviously, it's more complicated than this in reality, but everyone can typically understand this. Software is actually no different, especially in the modern era that we're facing today. So we have our frameworks and our packages and our open source open source libraries that we're using, combined with our own source code, which comes under that first component. But then we have our source control management, our IDEs. Then we have continuous integration and testing, the CI/CD department of it, which it goes through. And then we have really our finished products, our software artifacts, things like our Docker images, our packaged software. So it kind of follows a similar, if you want to think about it, a similar avenue that, the traditional supply chain of a traditional kind of physical products follow as well. But it's very nice to think about it in a linear process, that we have this nice kind of process that we flow through, but it's not actually the case. The software supply chain in reality gets quite complicated. That's because we can have software dependencies that are also dependent on other dependencies. We can have dual dependencies where components are dependent on each other. We can have lots of different packages, and everything can have dependencies and areas within it. So the software supply chain, whilst you can think about it in a linear line, is actually not. It can extrapolate and be quite complicated. So we definitely experience this. Why does this matter? Because it's complex, it means that we're actually vulnerable to a supply chain attack at multiple different stages of the process. It's not just our end artifacts and our applications that are vulnerable. We can be vulnerable to areas in our testing processes. We can be vulnerable to areas and vulnerabilities in our control, in our source code, and even right back down to the frameworks that we're using. So the software supply chain can be a really complex topic and one that's not really easy. And we've seen a huge shift of attackers really targeting this. So when you attack a component of the software supply chain, it can affect hundreds, thousands, millions, sometimes billions of different applications, components. We saw this with Log4j coming in, where it had this huge impact because so many different things were really dependent on it. And this has really changed economics of how hackers operate. We all like to think of a hacker as someone in the basement with a hoodie on, typing computers into a line. The reality is that hacking organizations operate much more like a traditional business than you would expect. And we've changed, and supply chain attacks have changed the economics that they follow, the hackonomics, if you want to go there. And so we've seen a huge uptick in this, right? Because it's the most profitable thing. You can target huge areas. You can target companies that may be really secure in their forward-facing components, but are vulnerable to some of their dependencies. So we've really kind of seen a huge increase, and we've seen this in the news. So we have to be aware of this. We have to take action against it. So I just want to talk very quickly through one software supply chain. We're going to run through the kind of anatomy of this, of exactly what happened, so that you guys can all kind of be familiar with what actually happened. The software supply chain that I want to talk about is Codecov. So what is Codecov? Codecov is a testing tool. It sits in your CI/CD environment. It's code coverage. It basically tests how much of your application is being tested. So we want to make sure all of our application is tested. Codecov gives us some figures of how much of our application is actually being tested. But early last year, there was a massive supply chain that affected huge amounts of Codecov's customers because they were breached. So what actually happened? So in Codecov's finished product, their artifact, their Docker image, there was a plain text credential. This credential essentially gave read-write access to attackers to modify a component in Codecov's the way that the Codecov's image is put together. It was a bash uploader script. The attackers were able to inject a malicious line of code, which basically turned Codecov malicious itself. What did that mean? Well, Codecov had 20,000 customers at the time of the breach. Every single time one of those customers used Codecov in their testing environment, the malicious version took all the environment variables, took the secrets that were being run in the environment to test the application. So it could have been database access strings, it could have been API keys, but importantly, it also would have been things like access to your internal Git repositories. So what actually happened was the attacker got access codes, got GitHub tokens or other version control system tokens to access the private source control of multiple different companies. Maximum would be at 20,000, but quite a lot. And they were focused on the larger customers, HashiCorp, Twilio, Monday.com. A lot of big names were affected from this breach. So we can see here how end product that had a vulnerability was exploited by an attacker. That update really went into the supply chain, and now everyone dependent on that component is now vulnerable. And now they've had malicious intrusions into their internal infrastructure because of that. So none of the companies that were actually ultimately breached, none of the victims did anything wrong. But because they had a component that was turned malicious, they were impacted by this. This is why it's so important to really secure our supply chain, because it's an area that we have limited control over. We have control over what we put into our supply chain, but even if you extrapolate that to dependencies of dependencies, we have limited ability to maintain that. So we can do everything correctly and still be vulnerable. That's why it's so important that we understand our supply chain and that we do everything to protect it. So in this case, there was hard-coded credentials inside the Docker image. There's also hard-coded credentials inside the victims' repositories. So Git Guardian, in case you're not familiar with us, we provide tools to help prevent that. So GG Shield is the tool, is our open source tool for developers. So if you're not using that, go check it out. It's the repository's on GitHub. You can put it into your CLI and prevent yourself from committing secrets. But ultimately, the supply chain can be attacked in lots of different areas, right? We've been through one, which is going through that testing stage. But this one here is from Salsa, which I believe is a Google initiative, this image here. And it's kind of showing a lot of the areas of where the software supply chain can be attacked from. So this diagram's depicting our software supply chain and kind of all the areas that we can really, that intrusions can inject themselves. So namely, there's our build integrity to ensure that the software is built from the correct sources, dependencies, and it hasn't been modified. That one's really important. There's our source integrity. And then really importantly, there's our dependencies. And that's what Feross is going to talk about now, is that dependencies component of our software supply chain. So with that, I'm going to stop sharing my screen. That was just a very quick introduction to kind of get everyone up to speed. And I would like to invite Feross to share his screen now and run us through the presentation, the main event, what you are all here for.
All right, thanks for that awesome intro. And with all that context, I think people will be really ready to go for my talk. So can everyone see the screen?
We can now. You're up and going.
All right, that's awesome. Cool, yeah. So thanks Mackenzie for all that awesome context on supply chain attacks. So everyone, I hope you're excited for our talk here, and I'm going to do an awesome demo as well of Socket and how it works at the end. But yeah, let's get started. So so just a little bit on my background. So most of this talk comes from my experience as an open source maintainer, writing some of the most popular open source libraries and being on the board of the Node.js Foundation. I really got a chance to witness firsthand the massive increase in the way that open source is used within organizations, as well as the increase in supply chain attacks. So now I'm focused full-time on this problem, scaling open source security for many organizations through Socket, which is a product that defends applications from software supply chain attacks, specifically around dependencies. So so this talk is really about the lessons learned being at the forefront of the rise of supply chain attacks. Like I said, I've been working on open source full-time since 2014, so I really saw this this firsthand. So before we start, what is a software supply chain attack? So Mackenzie already went over this a bit. The kind of official definition is like when a cyber threat actor infiltrates vendor's network and then uses malicious code to compromise software before the vendor sends it to their customers. That's kind of like the official or the sort of formal definition. But what does it really mean for us as JavaScript developers or as developers in general? For JavaScript, what this really means is an attacker somehow got their malicious code into your node modules folder, and that ended up getting used in your application. So somehow this dependency got compromised, and now you've installed malicious code into node modules. And so with that in mind, let's now kind of talk a little bit about why are so many supply chain attacks happening now? What has changed about the world to cause this this increase in attacks? I think it really comes down to three main reasons. The first reason here is that there's been a massive increase in just the number of third-party dependencies that we're using in our applications. This is because the way that we write software has changed. We're using a lot of cloud services, we're using no-code tools, we're using APIs, we're using a ton of open source packages. No one really writes software from scratch anymore. No one is sitting here, writing opening up a blank file and building an entire application. Everyone today builds software on the backs of other companies and tools and APIs and open source packages. One example of this is if you just look at large organizations, they use over 177 SaaS applications, just as kind of one indicator of the dependence that we have on others. But if you go to the developer context, and you look at an average application, you'll find that about 90% of the lines of code in an application actually come from open source dependencies. So, most of the code that's actually running in an app isn't written by the developer. It's written by these dependencies. And so, gone are the days of people copying code snippets from Stack Overflow and reinventing everything by writing it in-house. Really, developers are using dependencies very liberally because open source is just so useful. I mean, it lets us build powerful applications in days or in weeks instead of in months or in years. So we can really go fast by building on all of this awesome software that's out there. So let's look at one example of an application like this. So probably a lot of us have heard of Discord. Discord is an awesome chat application. It's built on a massive amount of open source. If you take a look at the dependencies that are used inside Discord, you'll see that it's using almost 20,000 NPM packages. And if you look at the commits in those, you'll find it's actually been written by almost 400,000 different contributors from 200 countries. So this is this is an amazing number of packages, an amazing number of people working together on this. And so in some ways, it's obviously very incredible that open source lets us do this. But on the other hand, if any one of these contributors, it goes rogue or decides to be, evil and put malware into their code contributions, then, this application and many others that depend on it on this open source will be affected. So, so this is kind of just an example of the way that we write apps today. Really, it's just we're using a lot of open source. One other stat here that kind of helps drive the point home is the average NPM package today has 79 third-party dependencies. And so when you install one package, you're actually installing 79 other third-party packages and depending on 39 other maintainers. So this is just like the way that the software seems to be written today. And so this just introduces new risks. And then I like to show this visualization. So this is a visualization made by the Socket team. This is the Webpack package. So Webpack is a very popular front-end tool for bundling your JavaScript dependencies and preparing the JS to be used by your users. And what you're seeing here is a visualization of all of the files and dependencies that make up Webpack. So every gray box is a package, is an open source package. And then every purple box is a file within a package. So let me restart this right here and you can see it from the beginning. So what you're seeing here, this is Webpack, big gray box. You open it up, inside you have other packages and you have other files inside, and we're going to keep peeling back the layers, one layer at a time. And you keep seeing every time we peel back a layer, you get more packages, you get more files, and you can just get a sense of the complexity here, the number of different dependencies that are used just for this one dependency Webpack. So the other reason why we're seeing more supply chain attacks is that change happens a lot faster than it used to. So we've gone from a world of releasing software once every year to sometimes hundreds of times per day in a lot of companies. So in this world, the security team can't really be a gatekeeper anymore, because every time you push to main or master, you may be running a deploy and deploying that straight into production. And so it's not really possible for the security team to kind of enforce rules anymore. And in today's culture of fast development, a developer might update a dependency and deploy it to production, in a couple of days or maybe even hours after that dependency was originally published. And this is partly due to folks are doing a better job staying up to date to avoid vulnerabilities. A lot of people are using tools like Dependabot to keep their dependencies up to date, as you can see in this screenshot here. And so as people are starting to take vulnerabilities more seriously, they've actually weirdly made themselves more vulnerable to supply chain attacks, because take this picture here, for example, this PR, right? It says it's updating express rate limit from version 5.3.0 to 5.5.0. Now, I look at this and I say, oh, a new version. That sounds like it's good, right? It's going to fix some bugs. Maybe it's going to make things faster. Maybe it's going to make things more secure. I don't really get much of an indication in this pull request about whether this is safe or not. And you can see this PR was sent a couple days ago, so this package is pretty new. There probably hasn't been a chance for very many people to review it. And so I don't know if this is safe. It probably is, but it might not be, right? And this is one other reason that we're having so many more of these supply chain attacks, is because there's so many dependencies and we're doing all this work to keep them up to date. We're updating a lot of versions. And every time we do that, we're bringing in new third-party code into our apps. Every single one of these updates is new third-party code. And today we're really not reviewing that code, or we don't really have a process for really understanding if that code is safe. So this brings up the question, how quickly should you update your dependencies? You could, a lot of I could say about 10 years ago, a lot of teams were on the slow side here. They would really rarely update their dependencies. And obviously, we've learned the problem with this is that it exposes you to known vulnerabilities, and so a lot of teams have actually done a pretty good job in the last 10 years of shifting over to this fast side here, where they're actually updating their dependencies pretty quickly. But as I just mentioned, this comes with its own downside, which is that you're exposed to supply chain attacks, because you're now pulling in code very quickly. And the quicker that you update your dependencies, the fewer eyeballs that have actually had a chance to look at that code. And not that many people are really looking at some of these dependencies. So this is really a challenge for a lot of teams here, is how quickly should you update? And really, I'm sorry, but I don't have really a good answer here. Other than Socket can actually help with helping you update fast and to give you some feedback on whether dependencies are safe, as I'll demo at the end. And then finally, the third reason is that the cost of attack has actually become so low that you're basically going to be attacked. It used to be that only big name companies were worried about being targets, but today, just by virtue of using open source, you will be attacked. I'll give you an example. So earlier this year, there was this tool called Amazon CDK, or Cloud Development Kit, and this is what users saw when they went to go run the Amazon CDK on their terminal. It printed out gibberish messages and included the text "liberty, liberty, liberty," as you can see, followed by all these weird non-ASCII characters and an infinite loop, which caused the program to hang. And so I'm not an expert in product or marketing, but this really isn't a good experience, and most companies don't want to deliver this type of an experience to their users. So what really happened here? Let's talk about what happened here. Basically, a few months earlier, the maintainer of a package called colors.js, which was one of the dependencies that Amazon used, had warned on Twitter he would no longer be supporting big corporations with his free work. And then he actually decided to sabotage the package. So when he sabotaged this package, he put the code that you saw to print out all this extra stuff in the terminal, and added these infinite loops. And in doing so, he actually affected many packages. Actually, 2.5 million. The package had 2.5 million weekly downloads, and he actually affected about 30,000 apps that we know of that are public on GitHub. Not to mention untold numbers of private repos as well. So this is the kind of impact that one person, one dependency going rogue can have on the ecosystem because of the way that we write software today, and we're so dependent on on each other. And then it's not just intentional sabotage. There's also packages that sometimes get taken over by somebody else, by an attacker. So I'll give you another example here. Last October, on this Russian hacking forum, there was a post that appeared here. You can see on the screen. This post was about a hacker selling the password to an NPM account that controlled an open source package with over 7 million weekly downloads. And they were offering this account for sale for $20,000. And 2 weeks after this message appeared, the package was actually compromised, and 3 malicious versions were published. And the attacker added malware that would execute immediately whenever anyone installed one of these compromised versions. So I'll just give you a quick preview, quick peek into kind of what the malware did here. I'm not going to get too much into it, but just to give you a taste of like what does the malware actually look like when an npm package is compromised. So let me draw your attention to this is the package.json file, and I'm going to highlight the pre-install script. So the pre-install script runs automatically anytime this package is installed. And so the attacker added this line so that their malware would run immediately when anybody installed ua-parser-js. And this is actually a very common technique. A 2022 paper found almost 94% of malicious packages used at least one install script. And so this is just kind of the main way that attackers like to deploy their malware today is install scripts. So let's actually take a look at the script that the attacker ran, so you can understand a little bit more about what do one of these attacks look like. So you'll see here the first couple lines are getting the user's country using a web service, and it's grepping for 4 country codes: Russia, Ukraine, Belarus, and Kazakhstan. And if the user comes from any of these 4 countries, then the malware will actually stop running and it won't proceed any further. So the user will be safe. And so probably what this means is that the attacker comes from one of these countries, because usually they don't want to antagonize their local law enforcement. And so we can probably assume that the attacker comes from one of these places, or at least operates in a group that operates in these countries. So let's say now that you're unlucky, you live in a different country, so the malware is going to continue running. So the next thing that it does is it checks to see if there's a process called JS extension that's running, and this is just the name of the malware. So if the malware is already running, then it will quit. Otherwise, it's going to actually try to infect you now. So it downloads a file from this amazingly suspicious-looking IP address. It makes the file executable, and then it runs it. And so this is actually going to run the malware. And you can see here it's actually a Monero miner, which is a cryptocurrency. So it's going to be abusing your system resources to mine cryptocurrency for the attacker. And then I'll show you the Windows version really quickly. It's very similar, but I'll just highlight one difference. So Windows users had a little bit of a different attack. So it also downloaded this extra DLL file, and then it registered this DLL file down here. And that extra step on Windows led to stealing passwords from 100 different programs and also the Windows credential manager. This was really nasty for Windows users. They actually lost a lot of potentially other accounts that they use on their machine. So we've seen headlines about these types of attacks. Whenever you see these, this is basically what's happening: is the package is taken over. The person who takes it over adds malware into the package, and then they use that to attack the users. So packages get hijacked for a lot of different reasons. Maintainers could use weak passwords. They might give access to the wrong person. They could themselves become malicious. They could be protesting something. They could get malware on their laptop. So there's a lot of reasons this could happen. So we've gone over kind of 2 what are called TTPs, so tactics, techniques, and procedures. And I want to just mention a couple more that you might see in malware. The next one is typo squatting. This is one of the most common techniques. So let's go over how it works. So there's a package called HTTP errors here, and it's very popular, has 52 million weekly downloads. It's awesome software, very useful. But say you're going to install it and you're starting to type this into your terminal, npm install, but you make a typo and you accidentally install TTP error. So this package is not okay to use. This package is very bad. It's malware. It's awful, right? You do not want this one on your computer. And it's so easy to make a typo when you're running npm install, and the consequences can be very, very dire. So what I'm going to show you now is using Socket, the tool that we're building at the company I work at. I'm going to show you what you can learn about the incorrect package here, the typo package. To say you were to look it up on our website, let me just draw your attention to this line here. You can see on line 112 that this package is actually including the child process. module, and then it's using that to run a shell command. And so we call that out here right in the file, where you can see it. And so if you actually zoom in there, you can see this is actually the command that's going to run. It's a very sketchy command. You do not want to run this on your computer. It's basically downloading some code from a bit.ly URL and then executing it. So this is quite a big difference for just a few characters mistake. And then finally, I'll mention one final technique, which is called dependency confusion. So this one can happen when a company is publishing NPM packages to their own internal NPM registry, and then they use a name that hasn't been taken yet on the public NPM registry. And then later, an attacker can come along and register that name on the public registry and put malware in it. And then many internal tools will get confused and use the public version of the package instead of the internal one. So we found a few examples of these on NPM. You can see a lot of them come from, they appear to conflict with very popular organizations that you might have heard of, like Yahoo and so on and so forth here. So there's a lot of these packages that are designed to confuse internal tools. And then if you open up some of these packages, the kind of code you'll find inside, it looks like this. And it's very heavily obfuscated. It's hard to know what it's doing, but it's definitely not something that you want to run on your computer. So this is just a sampling. I just wanted to give you all a taste of some of these attacks. What do they look like? How do they work? So now you have an idea. And I just want to emphasize, this is just the tip of the iceberg. At Socket, we were monitoring security incidents in open source packages, and we saw around 400 supply chain attacks in open source packages in just the last 30 days. So there's a lot of these happening. If you're curious, you can actually go to the URL on the screen in the footer there, and you can take a look at some of the other attacks that we've seen and see what Socket would have detected in them if you had Socket installed. So now let's talk about how you can protect your app, because I want to leave you with something you can actually do. So it's not hopeless. There's actually something you can do here, and this will give you a sense of what are some of the leading companies doing also that are protecting themselves. So the way it works today, when a developer adds a new dependency, this is what they and their teammates see. There's really no feedback in this GitHub diff view about what risks this change introduces. The developer or the code reviewer looking at this would have to painstakingly review every line of code of this package, as well as every line of code of its dependencies. So when somebody sends in a PR and it looks like this, almost no team is actually reviewing this dependency, right? I mean, when's the last time you got a PR from a teammate that looked like this, and then you went and actually did research on the package, right? Most of us don't actually dig into these dependencies, and the GitHub interface doesn't really give us much of that doesn't give us enough information about this dependency that would give us the context we need to really decide if it's safe or not. So like that raises the question, really, how closely should we be really evaluating our dependencies? So how closely should you audit your dependencies? And a lot of teams today are pretty much doing no audit. They just allow developers to add any dependency that they want, and that's the sort of norm today. And this is in some ways it's good because it's fast and it doesn't slow developers down. But the downside is it makes you vulnerable to supply chain attacks, because you're basically you're letting developers pull in third-party code that may have not, has never been vetted by anybody potentially, right? It could be anything in there. Now, if you you could imagine, okay, let's review every dependency. Let's go much more over to the full audit side. How does that work? So this is something that really only the very biggest companies do, companies like Google. And they'll do this because it's really the safest way. It's the gold standard way to make sure that you're not going to be hit with a supply chain attack. So it is very safe, but it's very slow because you have to review every line of code of every dependency. It's a lot of work. Almost no one except these really, really big companies can afford to do this. So, I think some of you might be thinking, well, hey, what if I use a vulnerability scanner? What if I use some kind of a CVE scanner and I just fix the dependencies that are, I use that to tell me if my dependencies are vulnerable or not. The thing is that malware is very different than a supply chain attack. vulnerable code is very different than code that has malware in it. So supply chain attacks or malware can take weeks or months to be discovered. And in today's culture of fast development, a malicious dependency might be merged into master and then running in production in days or even hours. And this isn't really enough time for a CVE or a known vulnerability to be created and to make its way into the tools that a lot of teams use. So this 2020 paper found that on average, a malicious package is available for 209 days before it's publicly reported. And so during that 209 days, there's no CVE published. And so developers really have no feedback that they're potentially installing a compromised dependency. And this is another paper from 2021 that found similar results, including that 20% of malware persist in package managers for over 400 days and have more than 1,000 downloads. So really just to drive the point home here, vulnerabilities and supply chain attacks are very, very different. They need different solutions. So vulnerabilities are accidentally introduced by maintainers, by the good guys, and they have varying levels of risk. Sometimes it's okay to put a known vulnerability into production if it's low impact, or you know that it's not possible for an attacker to actually exploit it. A lot of teams already have many known vulnerabilities in production, and they're working on mitigating those over time. And there's often time there because they may not be discovered or exploited before you update to a new version. So you usually have some time to address them. Now supply chain attacks or malware, on the other hand, is very different. Malware is intentionally introduced into a package by an attacker and almost never the maintainer, and it will always end badly if you ship malware to production. You don't really have a few days or weeks to mitigate the issue. You really have to catch it before you install it on your laptop or on a production server. So, using a vulnerability scanner to try to detect and block supply chain attacks is like looking for your keys under the streetlight, because that's where the light is, and that's not where you actually left your keys. So I think the security industry is a bit obsessed with scanning for known vulnerabilities, but it's really an approach that's too reactive to stop a supply chain attack. What you really want to be doing is working toward a position where you're much more proactively aware of what your dependencies are doing. So basically, let's talk about how to do that. So at Socket, we're focused on open source security. So these are some examples that I'm going to give you here, but the principle really applies to all forms of application security. So what we really want to do is provide visibility and feedback loops to developers. So we want to give the developers information about what their dependencies are doing, and we want to make it easy for them to fix any risks that are present in the packages in a quick way and see the results of that. So what do I mean by that? So today, when the developer is picking a dependency, they often check for a few things to make sure that the dependency is going to get the job done. So the first thing is they'll say, hey, does this dependency even do what I want? Does it get the job done, right? Then they'll say, does it have an open source license? Does it have good docs? Does it have a lot of downloads and GitHub stars? Does it have any recent commits? Does it have tests? And so you can look through and say, okay, this package generally feels like it's going to help me solve my problem, and then you might install it. So this is pretty normal. A lot of us do this process today. The problem is that this is kind of missing the real, this is missing the security question. What is it? How do you know if this dependency is safe? So ideally, if you were a security-minded developer, you'd be checking for more things than just that. You'd be checking for things like, is this package going to run a shell script when I install it? Does this package have native code, which makes it very hard to audit because there's an executable file in there and you can't read the source code for it? Does the package talk to the network? If so, which domains? Does it read environment variables? Which ones? Does it contain obfuscated code? Does it collect telemetry? Does it phone home? And if you could answer these questions, you have a much better sense for, is this package safe to install, or is it going to introduce risks into our code base? But right now, this is really hard to find out. These things here require a lot of research and a lot of work to investigate. As I mentioned, the status quo is that developers really have to work very hard to find out this information. This is a file diff you can see where it doesn't tell you anything. That tells the developer very little about this dependency. So how can we get to a position where developers have much more proactive information? So if you were to look this package up on Socket, you would find that we show you this amazing package page. You can search for any NPM package on Socket, and we'll give you information about the safety of it. You can see the scores we have at the top. We go into supply chain security, quality, maintenance, vulnerabilities, and license. And then we also call out any risks as big banners at the top of the page. So as you can see here, the event source polyfill package that I've been using in all these examples actually has a protestware attack in it. So what it's doing, and this is crazy to me that this is actually on npm still, but this package, if you install it in your app and you include it in your front end JavaScript, it will actually redirect your visitors to another URL if their language is set to certain languages. So what this means is it's actually hijacking some of your traffic to send to the URL of the attacker's choosing. And this is just sitting on npm today, and so you have to basically know this. And obviously, a lot of us aren't using tools like Socket, so we don't know that this might be in our apps today. How do you actually proactively protect yourself against this? Because you might not remember to check Socket for every time you install a package. And so to do that, we have a really nice GitHub app. So if you install the GitHub app, then anytime developers sending in a pull request to change code, Socket will come in and leave this comment, which contains information about the risks in this package. And you can see here we say, we include an explanation explaining exactly what this will do. So this empowers teams, it gives developers visibility, and it lets them know, hey, this package is, it contains risks that you should know about. And especially if the dependency has changed in its behavior recently. So for many years it behaved one way, and then suddenly it's now behaving a different way. That's a really, really strong signal that, hey, maybe we should take a closer look here. So this should be communicated to the developer before they update to this bad version. The key idea here is that the leading organizations, the leading teams, they want to shift security from being something like a gatekeeper to being something that enables teams to be secure by default. So that's the goal here. The goal is to enable teams to be self-sufficient and empower developers to be part of the solution. So using CI is a great way to do this because you can communicate it to devs in response to their pull requests. You can detect risky behaviors, dangerous API usage, all this kind of stuff, and you can put that information into the PR so the developer can see it and can act on it. So this is another example of Socket doing that. This is a package that is typo squat. So the developer actually installed the wrong package here, and you can see Socket comes in and says, hey, you might have installed the wrong package here. Are you sure you really wanted to install Bowserify instead of Browserify, which are very, very different packages. So really, this concept of adding a speed bump, double checking with the developer that they intended to do this is really, really great idea. And if you do this right, you can really increase velocity and empower developers. So if you do that, we can really live in this new world where we have a lot of third-party code, a lot of APIs, all these dependencies, but we can do it safely. And so security teams and developers can be on the same side because both teams really want to ship secure quality software, and we can do this together. So with that, I will jump into a quick demo of Socket, and you can get a sense for can everyone see me, by the way? Still, I hope so.
Yep, we can also see you. I've just hidden your screen whilst you're getting it setting up. So
okay, cool.
But yeah, just a quick reminder, some housekeeping. There's lots of questions coming in. That's great. Participation in questions and chat is rewarded in the form of Amazon gift cards. So we have 2 to give away today. So I gotta say, yeah, there's a couple of winners here. Team Netherlands, Robin is in the lead. If you want to knock Robin off the perch, then make sure you participate. Going on there. And for some, when you're ready, just oh, you've done it. Perfect. We're ready to go.
Cool. All right. Yeah. So here's an example of using Socket to learn some interesting things about a package. So let me just start off on our homepage here, and I'll give you a demo of this. So say that I'm an Angular developer and I'm looking for a calendar package. So I'd search Angular calendar. I want to include a calendar widget in my page. So if I search on Socket, the first thing you'll notice is you get these nice handy scores over here, and you get really helpful search results. And if I click on the package, you'll notice that you get issues, risks that are highlighted right here for you as a developer. And if I click on the Issues tab, you can even get like a full list of different risks that are present in this package. And I want to highlight one particular interesting risk here, which is telemetry. So this package actually contains tracking code that will track the behavior of your users as they browse your website or that kind of thing. And it's not documented really in the package. So this is something that Socket can highlight for you. Another example I'll show you is this is a package that has already been removed from NPM. So this one is malware. But just to give you a sense of kind of like what Socket would have detected if you had attempted to install this. You can see here, we detect the install scripts, we detect that there's a CVE, we detect suspicious strings, we detect network access. So before you install this package, you can actually see all these risks that are present. And if you're curious, you can even click and see a little bit more about what exactly would happen here. So you can see this is going to run a pre-install script. It's going to run this file here, node index.js. And you can click in and see exactly what would happen. So if I actually go to that here, index.js, take a look at what this package would have done to your computer if you had installed it. It would collect a bunch of tracking data about your machine, including your package.json file, your host name, your username, your DNS servers, stuff like that. And then it sends it off to this URL right here, which is owned by the attacker. So not something that you want to run on your computer. So that's another example there. And then finally, I'll just show you. Okay, so we've seen what Socket can find in packages, but how do you actually make this useful in your app? So if you go to the Socket website, you can click Install GitHub App and select your repositories that you want to protect. And within 2 clicks, you can actually protect your whole team and your whole organization from these types of attacks. So if you do that, then what will happen is whenever a developer sends a PR, let me show you what this PR looks like here. So you can see here we're adding Angular Calendar, that package from before. And it looks fine. I don't see anything suspicious here. I mean, GitHub's not showing me anything. But if I go into the conversation view, you'll see that Socket has come in and, okay, this page can load. Try refreshing. Okay, so yeah, if you come back to the main page here, you'll see that Socket has left a comment with a list of risks that are present in the package, including install scripts and telemetry, with information about how to disable it if you'd like to. So all the information is provided right here for the developer so that they can take action. So that's my demo. If you want to give Socket a try, again, go to socket.dev and you can click Install GitHub App here, and you can try installing it in your organization. It's free, so go ahead and give it a shot. And now we can do questions. So yeah, Mackenzie, do you want to pick out any that seem good to you, or do you want me to just read the ones that look good?
Yeah, let's tackle them. So there's quite a lot, which is great. So we can start. They all look pretty relevant. So I mean, let's just go through. Let's just go through them one by one for the moment while we got time. So the first one's from Robin. So when a platform like Codecov is breached, how would you as a customer remedy that? How would you fix consequences? So this one was actually kind of earlier on asked during my part. So I'll take this one quickly. But so when it comes to a breach like Codecov, I mean, if we take this specific example, they're all different. But what was happening with Codecov is the attacker was trying to get into private Git repositories. Why? Because there's lots of secrets in there. So they were basically trying to move into, that was their specific target. Now, it may have been they were trying to get VPN access. It may have been they were trying to gain data. And they could have been access to databases. There could have been lots of different reasons. And it comes down to good development practices. So don't have secrets in your repositories. That wouldn't have stopped them from getting into your repositories, but it would have stopped them from moving forward, right? So generally, they needed additional vulnerabilities to exploit in this case. Don't use production credentials in your test environments, right? Because then we're limiting our scope. So it comes down to good practices. Can you stop it? No. You can't. I mean, you were always going to use dependencies. We're going to use third-party tools. I'm not an advocate against that, but we just have to have the posture of being able to deal with a breach. And that is the last question that I will answer, because and I'll leave it over to Feross now. But the next question we have here is, how does Socket keep up with the rapidly growing number of open source libraries across JavaScript, Ruby, Java, Python? In other words, how long between new open source component being published and Socket doing an evaluation of the components? That one's from Brian Wallace. Thank you, Brian, for asking that question. That is too difficult for me. I'm leaving it over to you.
Yeah. Great question. Yeah. So obviously, there's a ton of open source packages out there. NPM by itself has 2 million packages. And if you look at the number of versions of the packages published, it's almost 10 million. So there's a lot of code out there, a lot of different packages to evaluate. So Socket, what we do is we watch for new packages being published, and we evaluate them in real time. So whenever a new version comes out, we immediately analyze it and look for risks. And that's so that we can help detect malware and get it taken down from NPM immediately. So we can report it to them, and they'll remove it. And usually they're pretty good about removing stuff within a couple of days. And in the meantime, we'll actually put the package that's malware into our own database, and we'll protect people who've installed the Socket GitHub app from installing that package. So that's the way we do it. Now, for so in terms of the time there, it's like pretty fast. So usually we get notified within a couple seconds that a new package is published. Then we start the analysis, and when the analysis finishes after a minute or two, then we have the answer if that package is safe or not. So so that's the way we do it. Yeah, so it's a lot of work, it's a lot of computation, but it's worth doing to protect people. So that's what we do.
That's really quite impressive, because I mean, at GitGuardian we scan all GitHub commits, and basically at Socket you guys are protecting another area. You're scanning all the npm packages. So yeah, that is a huge job. I will not understate that. But thank you. I'm sure the community appreciates that. All right, let's go on to the next question here. Okay, from Robin. Is there a way to force maintainers to be secure? This is an interesting one.
Yeah, I mean, so there's some of this happening already. I mean, NPM has actually recently announced that all maintainers of popular packages must use two-factor authentication to protect their accounts. There's certain things that you can do, that we can do as a community, to improve the security of all packages, such as enforcing two-factor authentication. But I think, in terms of, at the end of the day, what we're doing here is kind of crazy, right? We're trying to download code written by somebody we don't know, and we're trying to run it on our computer. And so, like, that should scare you. That idea, right, is just inherently kind of, it's just, there's going to be risks associated with that, right? No matter what we try to do. So what we can do is, we can scan the code before we use it with something like Socket. We can, we can create security standards for how the maintainers treat their own passwords and their accounts. But really, at the end of the day, you have to really either look at the code yourself or analyze it to understand its behavior in order to know if it's safe. Because you can write anything in a program. That's just kind of a fundamental thing about programs. It's just how it is. So I think there's things we can do around standards and encouraging good behavior. I think maintainers can look at their scores on Socket, but really, there is some limits to what we can actually do here.
All right. So you mentioned standards in there. So almost perfect. I don't know if you were looking at that, but magically the next question is: are there standards guiding development of dependencies? Do they exist? Where are they? Where can we find them?
Yeah, that's a great question. So there's some stuff being put out by OpenSSF, which is this awesome organization that is about securing open source for everybody. So if you look up OpenSSF best practices, they have some guides for making dependencies secure. There's also a guide that is being written right now for the Node.js project, which is covering kind of main main things that you can do to make your dependencies more secure. But there's some stuff out there, yeah. And you can also check the Socket blog. We have some information there as well on kind of best practices.
Okay, next one is from me, but you answered this one during in there, which was talking about like what are the indicators that we looked for. And I think this is a really big distinction. For me, it was about like where Socket differentiates from some of the others is that you're actually analyzing the packages to provide additional context and provide additional questions that you can answer when making the all-important decision to should I install it. You're not waiting for someone to find a vulnerability and report it. You're actually looking for them. That's really cool. I just thought I'd meet that. Socket, is it free forever or are you going to charge? I think a lot of people.
Yeah, so we're going to keep it free forever for open source repositories. And then for private repositories, it's probably going to be paid later. So we're still figuring out pricing. It's an early product, early company. But if you're using it today, I would expect most of the functionality to be the same going forward. If you're using it in a giant enterprise, then yes, you should expect to pay for it.
Now, this question here is interesting because you described some of this. You actually check the packages on NPM itself, but in your development workflow, how can you leverage Socket to kind of preempt you or prevent you from doing something silly? I think that's kind of like what the gist of this question is yeah, how do you prevent them from doing that or in an automated way?
Yeah, it's a great question. So we're actually working on a Socket CLI, which is going to be released probably in the next week. So I would say check out our blog, stay tuned. There's going to be a CLI tool that you can use to check the safety of a package before you run yarn add or npm install. So you'll be able to basically, you won't need to remember to go to the website to check this out. You'll be able to actually catch it before you run the install command and compromise your own machine. That's the right place to check for it. And so that's what the CLI is going to let you do.
And just to follow up on that, how do we keep in touch with your progress? Because I'm sure a lot of people here, I mean, at the moment, you're providing huge help for the community. How can we keep up with your progress? Do you have a mailing list or something? Because that's something that I personally would be really interested in knowing is when that CLI tool and your other projects, perhaps more frameworks, become available.
Yeah, that's a great question, Mackenzie. So there's two main ways. The first is if you go to socket.dev and you scroll down to the footer, we have a box you can subscribe to our newsletter and put your email in there. And we'll send about one email a month at most to just keep you up to date with how Socket is improving, what new features we have, that kind of thing. And the other thing you can do is follow us on Twitter. We're at Socket Security. So if you do at Socket Security, then you can keep up with us there as well.
Okay, so look, we only have very few moments to go. We've got lots of unanswered questions here, but I'll do one more just because I saw this one and it refers to GitGuardian's products, so I was excited when I saw it. Is there things that can check secrets inside packages before a Git repository? Yes, GitGuardian can do that. We can monitor your repository as a whole, or we have a CLI tool where you can actually check for secrets at a pre-commit hook, something to prevent them from going into your repository. So I'll send your additional questions through, and hopefully we can answer them offline. But we do have to wind up as we're coming to the end. So I'll first just announce the winners of the gift card. I saw something in the chat. How does it work? Basically, if you participate in the chat, in the polls, we didn't have any today, but in future, and by asking questions, basically, if you participate, then you can win. Then you can win some prizes. So we have 2 Amazon gift cards to give away. So the first one, I can't ignore my boy Robin, who's asked a lot of questions, participated a lot. So congratulations, Robin. You will win a gift card here. And I'm just trying to see who else. There were Brian Wallace as well. Congratulations. I will email you both after this and with additional information about how you can claim that. So congratulations, guys. Don't worry, we do this every month. If you didn't win a gift card this month, you can win one again next month. So follow our Crowdcast account and keep an eye on Git Guardian in our socials for the next webinars. But Feross, I want to thank you so much for coming here. It's not often that a CEO really makes the time to talk to the community, and what you're doing at Socket is really community-driven. So we appreciate you for trying to keep us safe. It's not an easy task that you've decided to embark on, but one we are very thankful for doing. So thank you so much for being here. It was really a pleasure to listen to you and to have you answer our questions.
Yeah, thanks, Mackenzie. This was really awesome and awesome questions from the community. So thanks, everybody.
All right, so that concludes it. Thank you all for being here, and I'll see you guys all next time.